compute the limit or state why it doesn't exist. As we get more and more complicated functions, we need to use different strategies and different theorems to try to tackle these. So the first thing I see is now we have different kinds of functions in here. We have a trigonometric function in here. You really want to get in your mind really quick that sine and cosine are the first two bounded functions that you're going to come across. What that means is, regardless of the argument, sine, even if we have division by 0, so we have a problem at 0, I see that 0 is not in the domain of this function, but regardless of that, values that I can compute, sine is always stuck between -1 and 1. So what we're going to use for this is we're going to use the squeeze theorem. What this is really asking, what it's going to show is, we have division by 0 here, which means 0 is not in the domain, which means we may very well have a vertical asymptote at 0. We want to know whether our function explodes or doesn't explode at 0. Using the squeeze theorem, we're going to show it approaches a finite value, so we do not have a vertical asymptote at 0, even though we may potentially have one because we have division by 0 in our algebraic expression. So how do we do that? Basically, they always say in the squeeze theorem you need to find two functions on either side of your function, one that's less than f and one that's larger than f, and I'm sure that that's the anxiety that this kind of problem brings, is that you're like, how am I going to build these functions? So what you have to do is you have to recognize when they give you a limit. There are other trigonometric ones where you'll compute them using slightly different ways, but in general, at first, the first thing you want to look at is, can I see that I have a trigonometric bounded function in here? I do. I have sine. So I immediately write out the bounded condition for sine. Sine is stuck between -1 and 1. Then what I want to do is be careful. In this case, I was careful to myself. I gave myself x squared, but depending on where x is and what power of x you have, I'm now going to build this function from this inequality. So being careful, I know x squared is always positive, so I can multiply both sides of the inequality by x squared and it won't change anything. So in this case, what I'm doing is multiplying this by x squared. So negative x squared is less than or equal to x squared sine of 1 over x, which is less than x squared. Now what that's saying essentially is our function is stuck between these two parabolas, negative x squared and x squared. I then compute the limit as x approaches 0 of negative x squared equals 0, which equals the limit as x approaches 0 of x squared. So because I know now that two outside functions go to 0, I know that the inside function also goes to 0 by the squeeze theorem. So this is equal to 0 by squeeze. At first, people also don't like this calculation because it wasn't equals, equals, equals. All I did was do a side calculation, built my functions, said this one went to 0, and then this one went to 0. So pictorially, what do we actually have here? What we're saying is this. I have x squared, and then negative x squared. And then, if I recall correctly, sine 1 over x is going to look like something like this. And then of course he's not defined at 0. But what that says is x squared goes to 0 from both sides. Negative x squared goes to 0. Our function is stuck in between those. And so our function has no choice but to go to 0 also. So there's no vertical asymptote. Again, what does that say? This limit is equal to 0 by the squeeze theorem. I want to do more, but the battery's dead.